Hi, my name is Cynthia Dickerson, and I work on an equation that pharmaceuticals companies and the FDA can use to ensure that the medicines you take are safe and pure. It all starts with complicated data, the kind that a pharmaceutical company gets when it scans its capsules. If you look at number 1, you'll see an example of this kind of data. Now, every hill or peak on this graph represents a different chemical in the capsule. And it's okay if these graphs don't always look the same. If you make your capsules on a hot, humid day, for example, you'll get more water in them. Or if you buy your ingredients from a different chemical company, that can change the size, shape, and location of the peaks a little bit. The other thing that can cause variability, though, is contamination. So, how do we know if these graphs look a little bit different due to normal variability or due to contamination with something poisonous? That's where my equation comes in. My equation runs on a computer, and it turns each one of these complicated graphs into a single point on graph number 2. Then, instead of comparing complicated graphs, we can just compare points. Points that are very close together represent capsules with very similar properties, while points that are very far apart represent capsules that are very different. So imagine we did this for a couple of different graphs. We would get clusters of points, like the red and blue ones. Now imagine for a second that the red capsules are contaminated, while the blue ones represent safe, pure medicines. If we had a new batch of capsules, say these green ones, and we wanted to see if they were safe, we could just graph them with the others. We can see that these fall within the safe cluster of points, so we put these in a bottle and we give them to you. Now, there's one word on my slide that I haven't mentioned yet, and that word is multivariate. Multivariate just refers to data that contains a lot of important information. For example, your age, your height, and your weight. That's multivariate data. The other thing that I haven't mentioned is that this process that we've gone through of turning complicated data into a single point and analyzing the clusters, well, that's the basis for artificial intelligence. So what am I getting at here? My project is to take this equation and put it into an artificial intelligence program so that a computer can test pharmaceuticals for their safety and purity, and it can order more tests if it gets confused. Additionally, I want to write a similar program that will run on a cell phone app to manage all of your healthcare data and warn you when it is predicting that you may have a flare-up of one of your medical conditions. In any case, this equation represents not only the past, but also the future of your health. Thank you.